For those who are all watching this special project presentation, this is in connection with our celebration with the College of Technology Celebration 2021. Especially for those who are watching, for my students of the College Information Technology Department. No, I hope that you're going to be watching also this one, since we are going to be also learning about a lot of things about Arduino. Okay, so my presentation this morning involves machine learning, and let me show you my presentation. Okay. So my presentation this morning involves machine learning using Arduino Uno. Okay, specifically, the project that we are going to be learning is Ultrasonic Censor and Lead project. My name is Christopher Y. Sabado, MSTCS, an Assistant Professor 1, and currently the Program Chair of the Bachelor of Science in Information Technology. So, our project this morning involves the use of Arduino, but let us first learn about machine learning. So, according to IBM, machine learning focuses on the application that learn from experience and improve their decision making or predictive accuracy over time. So, when we speak of machine learning, we're going to be embedding codes, instructions to a machine. Specifically, this morning, we are going to be using the Arduino board so that it would be able to learn and perform the needed tasks that we have instructed it. So, what is the Arduino board, or what is the Arduino? Okay? Arduino Uno, or the picture that is displayed, is the best board to get started with electronics and coding. The Uno is the most robust board you can start playing with. Uno is also the most used and documented board in the whole Arduino and Genio family. The main advantage of using the Arduino is its simple programming language. It's designed to make new users to get a glimpse and boost their confidence in programming. So that's it, no? That's how. That's a testament of how easy it is to use the Uno board. Okay, so let us dive into our project. Okay, the project's name is Ultrasonic Censor and Lead project. So what is an ultrasonic sensor? First, let us discuss this. Ultrasonic sensor HCRS04 is used to measure the distance of an object by ultrasonic waves. So meaning this device that is at the bottom, okay, emits ultrasonic waves. So the wave must be able to touch something, or it must be blocked for it to respond. Okay, so how does it do these things? It has pin outs. Okay, what you see at the bottom, there are pins. There are 4 pins. So what are these 4 pins? The first pin is the VCC pin, or voltage common connector pin, which needs to be connected to the 5-volt port of our Arduino. Next is the ground pin, which connects to the GND, or the ground of our Arduino board, that has 0 voltage. Third, is the trig pin. This receives the control signal, or the pulse, from Arduino. And lastly is the echo pin. Okay, this pin sends a signal pulse to Arduino. Okay, so when it detects something, this is going to be the pin that will send the signal. Arduino measures the duration of the pulse to calculate the distance. Now, what are the required or hardware requirements for this? Okay, so we need one Arduino Uno R3 board, one USB cable type AB, okay, that is shown in the picture, one ultrasonic sensor, one lid of any color, one 220 ohm resistor, one breadboard, and 4 jumper wires. Now, let us see the schematics, okay? So this is going to be the schematics that we are going to be employing in our project. So the schematics and the diagrams and the wiring in our Uno must follow this schematic, okay? Which was designed in Fredzing, okay? So you might see that the jumper cables are colored, but you may use any other jumper cable color, okay, for as long as you are going to be following the correct positioning of the jumper cables relative to the position in the Arduino Uno board and in our breadboard, including also the positioning of our LED light and our ultrasonic sensor. Now, for us to be able to perform this project also, aside from the hardware requirements, you have also software requirements. Actually, this is the actual picture of our project that I have recreated, okay? And after this presentation, I am going to be also showing the video of the actual performance of the project, okay, the video presentation. Now, as what I have said, aside from the hardware requirements, we also need software requirements. So this is the SketchUp Arduino project that we have, or the software that we are going to be using. So you could download this one, Arduino 1.8.13 software online. Just simply search for the version number so that you would be able, and the type of operating system also that you are going to be using. So let me explain briefly because since we are on a limited time, let me explain briefly the components of the code. So the code class here contains constants. No? These constants are your lid and your ultrasonic sensor pins. So we have here that trig pin, which we assign to 6, echo pin, which is assigned to 7, the lid pin, which we assign to 3, and the distance threshold, which is measured in centimeters, okay? So we also have a variable, floating point variable, which measures the duration of the distance of our of the blocking signal of the element that is blocking our signal. Then we have our void setup. This void setup is primarily used to assign the inputs and the outputs of our variables on top, right? So this particular setup initializes our serial port, right? We have our serial port 9600, sorry, and our pin modes for our trigger, our echo, and our lid. So this setup here will allow our board to monitor any signal that is coming from our ultrasonic sensor, and also controlling the lid for our lighting, okay, the lid lights. Okay, so next is the loop. Okay, this is going to be the process that will ensure that our ultrasonic sensor will behave according to what we are going to be expecting of it to behave. So first is we generate first the 10 microsecond pulse to trigger the pin. So what these codes here, the 3 line of codes do is this one will trigger the ultrasonic sensor to read what is blocking it. Okay. Next is to measure also the duration of the pulse from the echo pin. So when you say measuring it, when something is blocking the ultrasonic sensor, this set of codes here measures the distance, the duration of the distance and the duration of the blocking element of our uh, ultrasonic sensor. So, and it continues also here. So, this set of codes class, where guys, very short, will give us a clue on how the ultrasonic sensors, the lead light will behave. Now, let us try to demonstrate or watch how the actual demonstration is. Okay? So, let me show you the video of the actual demonstration.
Okay, so this is going to be our demonstration. So we are using an Arduino Uno R3 board, an ultrasonic sensor, and a lead bulb. So the concept of the project is that when you're going to cover the ultrasonic sensor, the lead bulb will light up just like this. Okay? So if the ultrasonic sensor is not covered, the lead bulb won't light up. Again, I'm going to demonstrate. Okay, so the practical application of this one is you could also use this for alarm systems, except instead of using the lead board or the lead light, you are going to be using the alarm system or the buzzer. In this case, we are using the lead light to indicate that the ultrasonic sensor is disrupted, meaning it will send an electronic signal to the lead to light up.
That ends my demonstration this morning. I hope that you have learned a lot from this very simple application, and I hope that students would be able to create a practical application on this Arduino project that I have demonstrated. Thank you and good morning.